to Saturday's edition of Cracking the Cryptic, where we have a massive birthday special for you today. So why is it a birthday special? Well, I need to start all the way over the Atlantic in Seattle, because I think, Sebastian, you've just turned 7 today, if I'm not mistaken. This is Sebastian Mantilla, whose daddy Andre got in touch with me and told me that Sebastian really enjoys watching the videos. So Sebastian, that is quite incredible to us that we have viewers as young as you are who enjoy what we do. Is a great thrill. So I hope you've had a brilliant birthday with, of course, lots of cake. And then we need to cross back across the Atlantic to talk to Jack in Cardiff, because it's Jack's birthday today. And Stephen, your mate, who goes under the Discord name of CypherHex, got in touch to say that you really enjoy the channel too. So this is all good stuff, and I hope you've had good cake as well, Jack. Now, and finally, we can get to today's puzzle, which is called Whispered Somethings, and this is by Riff Clown. And a little bird has told me that it's actually Riff Clown's birthday today. So we're going to do your puzzle, Riff Clown. Apparently this is a beautiful puzzle, so it seems very appropriate that we should do it on your birthday. I think the last time you were featured, at least by me, was on Christmas Day. I might be wrong about that, but I do remember doing a wonderful puzzle by Riff Clown in the shape of a snowflake, and I think that must have been Christmas Day. So yeah, it's not Christmas Day anymore. But anyway, 9th of April is obviously a very propitious day for Sudoku, and we are going to be trying this Whispered Somethings any moment now. I don't have much to tell you today, just an appeal as usual. If you enjoy the channel, please do like the video. Please do drop us a comment. We like comments, especially when they're kind, and even consider subscribing and all that jazz. That would be wonderful. Now, the rules of Whispered Somethings are as follows. Normal Sudoku rules apply. All lines are both German whispers and region sum lines. Don't worry, I'm about to explain what these things are, so if you are new to the channel and are wondering what these things are, do not worry, I'm going to explain it. Digits on region sum lines have an equal sum within each 3x3 box the line passes through. And there's an example here. It says e.g. row 6, column 6, which is that cell. Let's highlight that in blue. So that digit is equal to the sum of row 5, column 7 and row 4, column 7. It's equal to the sum of row, and those, so let's say this square was a 6. Now these two squares could be, I don't know, 2 and 4. So what we're trying to do is to make sure that for each box, each 3x3 box the line passes through, the digits on the line have the same sum. So 4 plus 2 equals 6. We could have 1 plus 5 here. They equal 6, and then we can't have double 3, so we'll have to repeat a combination. We'll have 2 and 4 down there. So you can see these two digits, let's make those grey, sum to those two digits, sum to this digit, sum to those two digits. So as we move through the boxes, we have to keep the sums equal. So let's do the same for this one at the bottom. Those 3 cells would have to add up to the same as those 3 cells. It's as simple as that. In theory, at least. Now, what else? Adjacent digits along German whispers lines must have a difference of at least 5. So that's telling you if this square was a, let's make that a 2. Now this square has to be at least 5 different from 2. So that would have to be a 7, an 8, or a 9. And then say it was a 9, this digit now has to be 5 different from 9. So that has to be 4, can't be 3, 2, or 1. And that's how German whispers lines work. Now, in this puzzle, all lines must satisfy both properties. So these lines are simultaneously equal sum lines and German whispers lines, which is a very cool idea. I have not seen this before. So anyway, do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And I'm actually tempted to get cracking with the line that is the example here because it's got this single cell instance of itself in box 5. Now it strikes me that it must be impossible for this to be a low number. Now, yeah, I suppose one thing I'm jumping over here is some logic I know about German whispers lines. let me explain that to you. It's a sort of secret, but not the secret, if you know what I mean. So let's think about how German whispers work. Because each adjacent digit on a German whispers line has to differ from the next by at least 5, could you ever put a 5 on a German whispers line? And the answer to that is no, because if you do put a 5 on a line, then the next digit is either going to have to be 0 or lower, or 10 or higher. Now, those are not valid Sudoku digits. So the first realization is that you can't put 5 on a German whispers line. Now, what's the implication of that? That means every digit on a German whispers line is either a 1, 2, 3, 4 or a 6, 7, 8, 9. And the thing is, it has to oscillate. Its sort of polarity changes as we move along the line. And you can see that, but let's make this a 4. What do we have to put here now? It has to be a digit 5 different from 4. So that would have to be a 9. The same would be true here. But then the next digit has to be 5 different from 9, and that takes us into the realms of 1, 2s, 3s and 4s again. So because you can't have 5 on a line, you have to keep oscillating up and down. Now, why does that matter for this digit, I think, in this puzzle? Well, it means we have to allocate it an upness or a downness. Now, if we were to allocate it a downness, that cannot work, because within this domino there must be an upness. There's going to be an upness here. And an upness is at least equal to 6, and 6 is definitely greater than 1, 2, 3 or 4, and we've got to add another digit to it, so that's not going to work. So I think this has to be high, and the moment we know that this is high and we have to give it a colour, we will give it the colour of the sun, of sunshine, to indicate a high temperature. The moment this is high, we can totally highify the whole line. All of those digits must be high, and all of these digits must be low, because we know that the line must oscillate. And that means that we... I don't know what that means, really. We probably have to go along the line and allocate digits, but I'm wondering whether we do that at this point, or whether we're meant to visit all of the lines. Well, I'm going to visit that line because I can do logic quickly on that line. Again, it's the same principle. If this cell was low, it has to be the sum of 2 digits here, one of which must be high, and that will break immediately. So that has to be high, which means it's sunny, which means that's sunny, and it means this is frigid and cold. Now, what about that line? Can we do the same on that line? Those... 7, 1, 14. Yes, yeah, we can actually. Right. Look at this little triple here. Now, of its nature, because we have to oscillate polarity as we move along the line, those 2 digits will have the same polarity. Now, could that polarity be high? If these are both high, the minimum they are is a 6-7 pair, and the minimum that digit would be a 1. So the minimum sum of that is 14, which means that these 2 cells, or these 2 cells, and these 2 cells would have to sum to 14, but it's not possible because of the oscillation. Even if we put 9 as the high digit, the next digit can't be higher than 4, and 9 plus 4 is only 13. So that doesn't work at all. Oh, it doesn't. Oh no, hang on. It only just doesn't work. 6 plus 7 plus 1 is 4. No, it only just doesn't work, but it still doesn't work, and that's good enough for us. So that tells us that the polarity of these 2 squares, while being purple, is actually also low. So they are cold digits, and this is high. And we get high, high in those cells. We get low, low in those cells. And we're gradually colouring the grid with high and low temperatures. Now, I think these lines, which look awfully symmetrical to me, are not going to be useful because here we've got a situation where the line's sort of ambiguous. We can already see that those 2 digits, whether they're high or low, are sort of mirrored on the other side by 2 digits that would be high or low there. So I'm not totally convinced that does anything. So, although I have to say, if I was constructing this puzzle, It's these sorts of lines. Symmetrical lines are always... Symmetrical lines at the top and the bottom of the grid are a bit sus, because that's the sort of thing that you might put in there to start the puzzle, rather than these sorts of wavy lines. No, but I'm not immediately seeing how to do that. So let's have a look at some of these actual blue and orange digits and have a think about what we can say. So this is a low digit, but it surely cannot be a big low digit, because if it is, it's going to push this up. So yeah, okay, if that's a 3, this is now at least an 8, and 3 plus 8 cannot equal a single digit number. So that's got to be, I think it can be 2. It can be 2 because we go 2 plus 7 equals 9, and that would work. So this square's got to be a 6, 7 or an 8. Definitely can't be a 9, or this wouldn't be able to be a 9. And this square's got to be 7, 8 or 9, because it can never be 6, because this is at least 6 in and of itself. Yes, you're right if you're thinking that's done nothing. Okay, let's start with this digit then. So this digit is also under a bit of pressure, isn't it? Because it can't be 6, because it's the sum of a high and a low. So it's at least a 7, which it probably can't be, because 7 is going to require 1, 6, 1, 6 and 1, 6 in all of those different boxes. Which, although I can't immediately rule it out, I'm sure it's not going to be right. Alright, we'll leave 7 in. So 7, 8 or 9 into this cell. Okay, yeah, and each blue digit along this line has exactly the same property as this cell. It must be a 1 or a 2. I see. Okay, this is really clever. It can't be a 3, because 3 would have to go next to 8 at least, and that's going to break this total. So each of these digits is also 6, 7 or 8. So we get... I'm not sure what we get, but it's not enough. At least I don't think it's enough. No, I still haven't found the way into this, have I? Okay, what's the minimum sum of those cells then? 1 plus 2. Yeah, you can't put 6 there, because if you put 6 there, you can't surround it with double 1, which you'd have to do, because they need to be 5 away from 6. So this is at least 7. So the minimum sum of those cells is 10, which would be a 1, a 2, and a 7. Now, does that mean something? So that means the high digit here. Yeah, okay. We need these two cells to add up to 10. So if we make the high digit a 7, this has to be a 1 or a 2, and this can't add up to 10. So that doesn't work. So both of those squares have to be an 8 or a 9, and that gives us an 8-9 pair in column 3. But unfortunately, I don't think that rules out anything from those. Oh, no, I'm wrong. I'm wrong. Oh no, am I wrong? Hang on. No, I was suddenly back to the world where this had to be a small total, but that's not true. So these have to be at least 8 or 9. So if that was a 9 and that was a 1, that would be... Oh, actually, look, you can't put a 1... Oh, right, hang on. Column 2. You can't have a 1-2 pair in those two cells. That's really interesting, because the absence of these two cells being able to be a 1-2 pair, these two cells being the ones I've just given the yellow flash, and they can't be a 1-2 pair, because then you're definitely going to repeat a digit in column 2, because this is also a 1 or a 2. But once you can't put a 1-2 pair there, one of these must be at least 3, which means one of these must be at least 8, because we must be 5 away from the 3. So we've at least got a 3-8 pair in one of these, and 3 plus 8 is 11. So now these three cells are adding up to at least 11, which means I want to say that digit can't be a 7 anymore. Because if that's a 7, it forces a 1-2 pair, so that is not 7. So this is 8 or 9. So can you put a 4 into either of these cells? I'm just wondering, because you can't put 3 into them. If you put a 4 in one of the blue cells, you're going to have to, this is going to have to be 9. So you're going to have to go 4, 9, 1 minimum, which is 14, which is too high again. This is really clever stuff. This is totally original. I've not seen this combination before, and it's refreshing all the logic, both of the region sun lines ideas and the German whispers. Yeah, these 3 cells, if you put a 4 in one of those, because the adjacent orange digit would then have to be 5 away from 4, it would have to be 9. So the minimum you could then put into these 3 cells would be 4, 9 and 1, which is 14, and that's not possible to reach, because even if you go 9 and 4, you only get 13. So that tells us that this is a 1-2 pair, because it can't include a 3 and it can't include a 4. So the low digits are a 1-2 pair, and the total we're heading up towards is either, therefore, 3. It's either 11 or 12. 11 or 12. Now, does that tell us anything useful? Yes, it does. I think it means this is a 2-3 pair. Okay, given that we know each of these, we know that those 2 cells there and those 2 cells there either add up to 11 or 12. Neither of these cells can be a 1. But by the same token, neither of them can be a 4, because if they're 4, you force a 9 into the adjacent cell, so you force the total to be 13, which is an impossible total here. So these are, I want to say these are a 2-3 pair. And now they must add up to the same number. And the only way that works is if we combine the 2 with the higher number. So one of these is 2, 9, and one of them is 3, 8. And therefore they're adding up to 11, which means this is an 8 to make that 11 with a 1-2 pair. Sorry, I'm not sure how much of that you heard, but that was fairly dramatic. Anyway, I think everything is okay now. And yes, yeah. Anyway, sorry, back to this. What on earth was going on outside my room there? I do have an idea what it was, but at least it's stopped now. So yeah, we got this 11, didn't we? We got the 11. We can get rid of 8 here. We've got the 2-3 pair here, so that's a 1. So now we know the difference between this and this is 1, which means that this can't be 9 anymore, because if that's 9, that needs to be 8, which we just said it can't be. And now we can... oh, this 1 is looking at that, so that's a 2 and that's a 1. So 1 is in one of these 3 cells. And, oh, I don't know what I should do. 3 and 4 are both cold digits in this puzzle, so I'm going to highlight those as well. Make me feel like I'm making progress. Right, how do we do this? 8 is not in that cell anymore. Is that helping us know what this total is? I can see that's not 8. So this is, oh right, so this is 7 or 9. Oh, but it still could be 7 with... Can it still be 6, 1, 6, 1, 6, 1? Maybe. Maybe it can actually. Maybe it's, in fact that's what it's going to be, because it's not getting ruled out. At least I don't think it is. Right, what do we do next then? 11. 11 here. So we know 11 is going with either 9, 2 or 8, 3. So if that was 8, 3, that would be 7 and that would be 6. Oh, and yeah, that's interesting. The moment you get, if I got a 6 here, I would know that this couldn't be 7 immediately because that couldn't be 6. So if that's 8, that forces this to be 7. No, not 7. If that's 8, that has to be 9. But the problem with 9 there is it takes all of the tension out of each of these region sum lines in boxes 6, 8 and 7. Oh, okay. I'm now wondering whether it is these lines. Let's think about this for a second then. We've got, however these lines work, they've definitely on one side of them got 2 high digits, haven't they? In fact, let's label up the line with some neutral colours. So whatever the polarity of this cell is the polarity of that cell and the polarity of that cell. So those are all the same polarity and these are all the same polarity. So no matter whether yellow turns out to be high or purple turns out to be high, one side of this line has 2 high digits in a box. That means the minimum sum we're heading up towards is a 6 plus a 7 plus a 1, which is 14. And so let's say this is the high one. If this is adding up to 14 at least, this has to add up to 14, but it can't do that. Those 2 cells have to be low this time. So they can be 3 and 4 going with a 9, which would be 16. Okay, so the region sum line for both this one and this one is either 14, 15 or 16. Now, can we do any better than that? Well, so that the central... yeah, I can actually. Right, let's just bear with me here. So what I'm saying is the minimums, if this is the high side of this line with a 6, 7 there and a 1 here, that's the minimum I can make those cells add up to, 14. How could this, which is a high digit, be an 8? Or indeed a 7 or 6, but let's look at 8 specifically, because I think 8 is the interesting one. If that's 8, the maximum size the low digits can be, because they have to be 5 different, is a 2, 3 pair. And that's only 13, and we know that we're looking at least 14. So the middle digit here has to be a 9. Oh, right, good grief. Right, I've done this puzzle backwards. I've done this puzzle totally backwards. Okay, sorry. I did not appreciate this. This is just ridiculously clever. Right. Why is it ridiculously clever? Well, I'm sure you've all spotted it now, but look. We've just worked out that the middle high digit on this line, and we don't know which side it is on this line, is a 9. But let's think about the middle low digit now, which if this line was in this orientation would be this cell. How could this not be a 1? Let's try a 2. If we try a 2 here, we're forcing these now to be a minimum of a 7, 8 pair. But 7 plus 8 plus 2 is 17. And even if I max those out with 3 and 4, which I actually can't do here, but if I did that, I'd only get to 16. So this can't be a 2. And why does that matter? Well, it means it's always a 1. But because these lines work, because these lines are the same, that they're just reflections of each other, that means that in those cells we have ourselves a 1, 9 pair, because the middle digit in each little string has to be a 1 or a 9. Isn't that beautiful? So this this, well, I can. The thing I'm seeing is it's going to give me a 1, 9. It's going to give me this digit here as a 2. And that immediately, therefore, rules out the ability of this to be a 7, because this has to go... Well, in fact, that has to go with 7 now, because it can't go with 6, because it needs to be 5 apart on the line. So that's 2, 7, that's 9. And that means... Oh, goodness me, I don't know. Oh, well, one thing it means, which might not be important, but it might be important, is I can now colour the top line. Because of this relationship, but if this is low, this is high, those all have to be purple, don't they? Which means these all have to be yellow. And we're only a step away from being able to... If I can get one digit on either the bottom line or the top line, I'll be able to colour it with the proper highnesses and lownesses that we're trying to get to. So I got my 2, 7 here. That can't be 6 anymore, because 6 can't go with a 3 here. So the same is true there. I've not got my head around this puzzle at all. Right, so this could be 7, 2 or 8, 1. That's the only options. Okay. Oh dear. How do we do this then? And in particular, what I really want to know is how I do the lines. How do I get knowledge about which way round these 2 lines go? Is that supposed to be obvious to me? The answer to that is, I don't know. Do we know something about these lines? I know these 2 add up to 9. So if that's 8, that's 1, that's 9. 11. That's 2. Okay, so there's a little parity thing going on there. One of these is always 8. I think that's true, because either this is 8, 1, adding up to 9, in which case that's 9, and that's 2, or this is 7 and this is 2, which makes that 3 and that 8. So one of these is always 8 and one of these is always 2, because we're heading up towards odd totals. I'm just going to highlight that. So does that matter? We've got a 2 in this row. And this is a 1 or a 9. And it's the same polarity as that. That strikes me as very tricky indeed. Yeah, this doesn't work. That's really clever, but it's really hard for... I don't know why I just couldn't see that immediately. It's this 4, isn't it? This 4 is doing magic. So the point is, what would happen if yellow... In fact, let's get rid of the yellow there, because that's not going to help matters. But what would happen if yellow was blue? If yellow was blue, I'd get 4 blues in this row. And these 4 blues need to be the numbers 1, 2, 3 and 4 in some order. Which one of those are we going to make 4? We can't make any of them 4, so it doesn't work at all. And that's absolutely glorious, because that means that yellow is orange. These are the proofs that we can come up with on Cracking the Cryptic. So yellow, all the yellow cells actually are orange, and all of the purple cells are actually blue. I know you didn't know that before, but now we do know that. And now now we know the order. So now we know that the blue digit is the cold one, and that's the high digit, so that's a 9. Surely that's going to do wonders for us, isn't it? He says, looking desperately at how this is going to work. So that's the low digit, and that's the high digit. Sorry, another interruption. Speaking of birthdays, someone in the house, it's very nearly their birthday, and there's a lot of excitement going on, as you could probably hear. Anyway, we're still doing okay. We've just had this marvellous breakthrough where we've got the 1 and the 9 on this line. And now for our next trick, we are going to... How does that help us? It gives us... No, it doesn't give us... I was about to say it gives us a 9, but it doesn't give us a 9 in box 2. It nearly does, but it doesn't. 9 in box 6 is only in one of 2 places. So 9 in box 9 is in one of 2 places, I think. Oh dear. Okay, 1 can only be in one of 2 places. What we might need to do next is to pencil mark these lines and see how they work. Oh no, that sees all the high digits. 7, 8, 9. So that's a 6. So now this line, that square can't be 6 or 9. It sees both. So that's got to be 7 or 8. And that means that this line is summing to either 14 or 15, which must mean something for the blue digits in box 3. So 14 or 15. Oh, no, it doesn't do anything. That's really mean. Is that really true? No, that can't be 4, because that would require a 9 here, which this can't be. But I still don't think we can... That could be 1, 4, or it could be 3, 2, or it could be 2, no, or it could even be... No, it could even be 2, 4. Right, that is very, very mean of Riff Clown. So we don't know how to do that. This square's a 3 or a 4. It can't be a 1 or a 2. It's really strange. None of these blue digits all seem to be looking at these various difficult blue digits we've got left. Oh, right. But I've got a 2 in one of those and a 2 there, so there's got to be a 2 here. So maybe this is going to help. We must bluify the 2. We must get rid of the 2 here, which we said that these were adding up to it's more noise. 14 or 15. So 5 or 6 into those squares. So if that's... Oh no, it's still fine. Oh, 3, 4 might be impossible now. If that's 3, that becomes 4. And that means we've got 16 here, which is not a possible total, is it? We need a 9 here for 16. Right, so that is not 3. I've now got a 1, 2 pair in this column, which does diddly squat, I think. Oh, you rotten thing. No, okay, sorry, that's no good either. Wow, what are we meant to do? Probably Sudoku. I hear you all crying. That's normally the thing I'm not doing, isn't it, when I get stuck? Right, let us expeditiously turn our minds to Sudoku. Although actually there's not a lot of... It doesn't look immediately like there's a lot of Sudoku we haven't done here. We've got an 8-9 pair in column 3. Oh, okay. So 9 is in this domino, which I hadn't appreciated before. So 9 is in one of those 3 cells in box 1. Ah, crikey. Right, okay. 9 in the bottom row is forced now. There's a 9 in one of those, so 9 is not here. There's this 8-9 pair here, so 9 is not there. 9 is in that box already, so I think that's the only place 9 goes, in the bottom row. So these 9s now cancel. No. Well, yeah, sorry, I was just trying to do Sudoku in box 6 and wondering why I'd already got this pencil mark, but that does seem to be valid. But anyway, these 9s cancel out on the bottom. Oh, right, yeah, this is good. This is very beautiful. Right, if you look at, we know those 3 add up to the same as those 3, but now we've got the same digit on both sides of that equation. So that means these 2 have to add up to these 2. So how could this be a 1? If this is a 1, those 2 would also cancel out, and we would have a contradiction that orange was the same as blue. And although we proved that orange was the same as lemon, we cannot have a situation where hot is the same as cold, not even in this puzzle. So that cell is not 1, which seems to give us a 1 in this box. Oh, yeah, okay, this is interesting now. This is very interesting. Oh, maybe it's not. But what I'm noticing is I've now got a 3-4 pair here, so I'm going to be able to get this digit, because this adds up to 16, so that has to be a 6 to make the maths work. So now there's a 6 in one of those 2 cells in box 8, which means we get a 6 in one of those 2 cells in box 7. We've got... okay, where does 8 go in box 8? It's got to go in the same place that 6 goes. We've got a 6-8 pair here, which gives us this digit as a 7. And that's a 7. So these 2 are both 7 too. This is now a 3. Adding up towards 11, so that needs to be an 8, that needs to be a 9, that needs to be a 2. This has to be a 5 to complete this box. These are both high digits. Now, what about those 2 squares then? So they're from 3, 4 and 9, I think. Still doesn't... Well, that's not... Oh, okay. Oh, that's weird. So that's a 9. Oh, I see. I was wondering why I couldn't fill this 9 in before, but I've only just got this 9. So I do forgive myself on this occasion for not doing instant Sudoku. I've got a 3-4 pair now in column 4. And I've got 2 in one of those cells. Oh no, I didn't mean to do that. I want to put a 2 in one of those 2 cells. Okay, there we go. I want to... What else should we be doing? Oh, this 3 is seeing that digit. Oh, okay, so that gets me a 4 there, and a 3 there, and a 4 there. So 4 is in this domino. 3 is in one of those 2 places in box jobby job up here, blocks 2. 2 is also in one of those cells. Look, that is a 2-3 pair, which means we can bluify that, and we now know those squares have to include 5 and 7 and 8, which doesn't seem to be resolved, which is very mean. Okay. Okay, so what do we do now? We've got a 7 here, so that becomes a 6, which means that must be a 7, which means that's not a 7. So is this 6 doing some work for us? Not really, I don't think. This is a deeply intricate puzzle, isn't it? There is a lot going on in this. Now in this column, we've got 1, 2, 3, 4, so we need 5, 6, 7 and 8. I don't know if that's resolved or not. And I want to get either this 3, 4 or this 1, 2. I think either of those would be very handy. Or can we do any more Sudoku? 6 is a little bit restricted in box 1. So now 6 is a little bit restricted in box 3. 7 is being very recalcitrant, unfortunately. 1, 7 and 8 in row 8. So, oh, that's a naked single. Oh yeah, that is a naked single. These 1s are looking at it, so that's fine. We get a 1 here. We get a 1 there at the top of the grid. Beautiful. Thank you, Rift. Ah, That gets me a 2 here. And that gets me a 1 here, which means this is an 8. So now we might be away, as this 2 is giving me a 2 here and a 3 here. So is that helpful? That is the question. Surely it's doing something. 3, yeah. Where does 3 go in box 1? It seems to have to live in the same cells that the 6 does. So there's a 3-6 pair here, which is looking at this cell. So that is a 4, which means this is adding up to 15, which means that has to be an 8. There we go. So that's an 8 and that's a 6. That's a 5 and that's a 7. And these two squares have got to be a 5 and a 7 to make the world add up. That doesn't seem to be resolved. 5 doesn't deserve a colour, but 7 needs to be hot, so we can fill that in. 7's in one of these two cells. 3 and 6 we need to resolve, don't we? So we can't quite do that. And we need 4, 5 and 8 in the top row, so that's an 8 by Sudoku. This is a 4, 5 pair. And this 8 is hot. And there's a 7, 8 pair there, which is resolved. Great. So we get 8, we get 7, we get 7, we get 5. These squares are going to be 1, 3 and 6, which is probably resolved somehow, some way. But that seems to suggest that this is 8, which suggests this is 8, this is 2, this is 9, this is 9. That's not 1. We've already got the 1 here. Let's not be overzealous. 2, 2, Barley McGrew, Cuthbert, Dibble and Grub. That's a 2 by Sudoku. I think we might have done all the 2s. Yes, we do, and all of them deserve to be blue. Have we done all the 1s? Well, I have no idea what that just did. 3, oh no, hang on, double clicking is not working with all the colouring, so we've got to, I think we've got to abandon that and keep going with the low-tech way. 3, 5, right, what are those cells? 3 and 5, oh, that's doable. 5 and 3 go in. So that's a 6 by Sudoku. This is a 1, this is a 3. Therefore that's a 3, that's a 3, that's a 3, that's a 6, that's a 6. We need 4, 5 and 9, which makes this a 9 in box 7. 4, 5 pair here, which somehow doesn't seem to be resolved. And this cell needs to be a 4 or a 5, which is also not resolved, but hopefully will be by something in row 6 in a minute. Right, so what's this square? That's got to be a 7. So that's a 7. This column needs a something, a 5, I think. And this box needs a 5. So we're just left with 4s and 6s here, which is that way round, and that's great because that gets me this digit, which gets me that, that, and that. That's a 4, that should be a 6. And now hopefully with little hold up we should be looking at 4 and 7, so 7 and 4 and tick. Yay! Right, now I know you're going to get cross with me if I don't highlight all of my high digits in orange. And let's make sure we've done that. And all of my low digits in blue. And I've now done that. I should just be left with 9 5s uncoloured. That's a super puzzle, Rift Clown. That really is. That is it's a very clever idea to mix these two rules together, but it's very, very elegantly executed and completely fooled me with the cleverness of this line here and this line here. I even said to myself, that's likely to be, you know, that looks deliberate from the constructor to put these symmetric lines at the top and bottom of the grid, but it didn't occur to me at all that they were actually restricted ab initio, and I don't know whether that would have made the solve a bit faster if I'd got to that 1-9, these 1-9 pairs in column 5 and 8 a bit more swiftly. But I hope you enjoyed it. I hope you had a go. Let me know in the comments. I do enjoy reading them, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.